Hey everyone, welcome to day 2 of our exponent rules. Today we're going to be talking about division, fractions, all of our favorites, definitely, right? So you'll notice we still have a lot of rules on the sideboard that we haven't covered yet. And so today we're going to knock a few more off the list. And if you had issues with the worksheet yesterday, remember that the answers to all of those are on Moodle. And we're going to be able to work through them together, so no worries there. So let's take a look at some new rules here. So, first one we have here is that we have the same base, once again, on the top and bottom. This is very similar to the one we had yesterday, where we had b to the m times b to the n. This time we're just doing division instead. So let's start with looking at something with numbers again, since it seems like that's been pretty easy. So let's look at something like, I don't know, 2 to the 4th divided by, I don't know, 2 to the 7th, something like that. Let's think once again about what exponents really mean. This means we have 4 2's on top, and on the bottom we have 7 2's. Now, as I'm writing this out, my guess is some of you started to get a little itchy about it. You said, oh my gosh, I can cancel some things out. If there's one thing algebra students know how to do, it's how to cancel things out of fractions. So let's see how many of these cancel. 1, 2, 3, 4 of them cancel. What am I left with on the top? Well, all my 2's canceled, so I just have a 1 left on the top. And then on the bottom, I'm left with 1, 2, 3 2's, which is 2 to the 3rd. So where did that 3 come from? Well, the 4 and the 7, it looks like if I subtract those, something might be going on. And let's see if we can try that with a little bit different something. Let's try like x to the 8th divided by like x squared. So that would have 8 x's on top. 1, 2, 3, 4, 5, 6, 7, 8. And on the bottom, we would have just 2 x's. So 2 of those are going to cancel. Let's cancel out the one that I didn't make very well. So what do we have left? Well, on the bottom, I'm just left with 1. On the top, I have 1, 2, 3, 4, 5, 6 x's. So I have x to the 6th on top. And on the bottom, I just have 1 left, but I could just write that as x to the 6th. So once again, I get a 6 here. How do I get that from 8 and 2? Well, once again, it looks like we're subtracting. And that's exactly how you do this. So b to the m over b to the n is b to the m minus n. So yesterday, we added those. Remember, when we had the multiplication, we did b to the m plus n. When we divide, we just subtract them. So if the top is bigger than the bottom, really easy because we just end up with doing 8 minus 2. If the bottom is bigger than the top, the way a lot of people remember this is they just say, well, I'm going to still subtract. So I'm going to do 7 minus 4. But because the bigger number's on the bottom, that's where the number ends up. So 7 minus 4 is 3. So I know there's going to be something about 2 cubed. And because the bigger number's on the bottom, that 2 cubed has to stay on the bottom. So let's try some examples with that. Start out here with x to the 4th over x squared. So that's going to be x times x times x times x over x times x. Just showing this how it works. So we cancel out 2 of them. We ended up with just x squared, which is exactly the difference of the top and bottom. X to the 4th over x squared, just subtract 4 minus 2. Let's try the next one here. So we have z to the 5th on top and z on the bottom. So technically there's a 1 there. And if you think about it, we have 5 z's on top, we have 1 on the bottom. One of those is going to cancel, so we're going to end up here with just z to the 4th. That's our answer. Up here, we got y over y to the 6th. So this is y to the 1st power. So we could think, okay, 6 minus 1 is 5. 6 minus 1 is 5. But since we have the bigger y on the bottom, we're going to end up with 1 over y to the 5th. The other way to think about that is one of the y's cancels, and we're left with 5 still on the bottom. The 1 on the top goes away, and we're left with 5 on the bottom. Let's take a look at this one. Let's start with our numbers. So 10 divided by 2 is 5, and then 8 minus 7. So it's going to be 5 times b to the 8 minus 7, which is just 5b. Because 8 minus 7 is 1, so we just have 5b to the 1st, which is just 5b. Now this one, we could do 3 minus 3, which is 0. So the 5 over 2 we can't cancel. 3 minus 3 is 0, so it'll be 5 over 2x to the 0. What did we learn yesterday about things to the 0? They're just 1. This is just 5 halves. And we're done. You can see that because x to the 3rds, they just cancel out. And we just end up with 5 halves. So that's almost a trick question. All right, the next one is where you have a fraction to a power. Well, the way I think about this is, let's say we have a fraction like 3/4, and let's say we're taking it to, like, I don't know, the 5th power. So what that fifth power means is I have 3/4 5 times. So 3/4, 3/4, 3/4, 3/4, and 3/4. There we go. Now, multiplying fractions maybe is not our strong suit, but it's pretty easy. We just multiply across the top and multiply across the bottom. Well, I have 5 3's on top, so that's 3 to the 5th. And I have 5 4's on the bottom, so that's 4 to the 5th. And that's exactly how this works. We can just distribute it to the top and to the bottom. So this is a lot like the product to a power we had yesterday, where we said, oh, that's just a to the n times b to the n. It's exactly the same thing here. So this is just going to be a to the n over b to the n. Pen doesn't like to write up high there. We can just distribute it to the a and to the b. And we're done with that. All right, let's take a look at some problems with that. X over y squared. It's just x squared over y squared. 3 over z to the 4th. That's 3 to the 4th over z to the 4th. 3 to the 4th is 81, so we just write that out. 81 over z to the 4th. Down here we've got 4/5 squared. Well, that's 4 squared over 5 squared, which is 16 over 25. Should be circling my answers here. X over 2 to the 5th. X to the 5th over 2 to the 5th. And 2 to the 5th, let's see, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So it's x to the 5th over 32. And that's it. Not too bad at all. So the solving for x with the fractions might be a little bit more tough, but it's really not too bad. This first one, we have the same base on the top and bottom. So what do I do with my exponents? I subtract them. So I have 2 to the 9 minus x has got to be equal to 2 to the 4th. Well, the exponents have to be the same since we have the same base. So 9 minus x has got to be equal to 4. Add x to both sides. So we have 9 equals x plus 4. Subtract 4. We have x equals 5. Which makes sense, because 9 minus 5 is definitely 4. This next one over here, 2/3 to the x equals 16 over 81. Let's use our fraction to a power property. So that's 2 to the x over 3 to the x is equal to 16 over 81. Well, let's see. 2 to the 4th power is 16. Oh, and 3 to the 4th is 81, so x has got to be 4. Now that one's a little trial and error, because you kind of see, okay, well, how do I make 2 go to 16? Well, I have to take it to the 4th power. That also works for the 3. Last one here, we're going to subtract these exponents because we have the same base on top and bottom. So we have 8 to the x, oops, 8, not x. We have 8 to the x minus 23 is equal to 8 to the 12th. So now I know that these exponents must be the same. So I have x minus 23 is equal to 12. Just add 23 to both sides. And we end up with x is equal to, let's see, 35. Kind of cool. So putting everything together, this first one I made up. This second one is a problem from your yellow sheet, so you can actually give it a shot if you want to. Try it along with me. Let's try the first one here first, though. So we have a fraction, all to a power. So remember, the power has to go to the top and to the bottom. So we'll have the top, 3xy squared, z to the 7th, all raised to the 3rd power. And on the bottom, we have 4yx to the 4th, z cubed, all raised to the 3rd power as well. Because we had to distribute the 3 to the top and to the bottom. We can't just do it to the last term. That wouldn't make any sense. The whole top's got to be the 3rd. The whole bottom's got to be the 3rd. Now we use our product to a power formula from yesterday, our rule that's also still up on the sideboard. So we're going to do this 3. It's going to get to everybody. Shoop. Everybody gets the 3, including the number. Don't forget the number. So we'll have 3 cubed times x cubed times y squared cubed. Now, some people just do that all in one step. They say, well, y squared cubed, I multiply those. It gives me y to the 6th. And then I have z to the 7th cubed. On the bottom, we're going to have 4 cubed times y cubed times x to the 4th cubed times z cubed cubed. A lot of cubing going on there. So now, let's multiply everything out. So we have 3 cubed is 27. X cubed. Y squared cubed is y to the 6th. Z to the 7th cubed is z to the 21st. On the bottom, looks like we have 4 cubed, which is 64. Y cubed x to the 4th cubed is x to the 12th power. Z cubed cubed is z to the 9th. So now we have to look at the top and bottom and see what can I cancel out. Well, we have 21 z's on the top and 9 on the bottom. So how many of those are going to cancel? Well, let's see. 21 minus 9 is 12. So we'll have 27. And we just said it doesn't matter what order we write this. Let's just write the z in the front. Z to the 12th. And all 9 z's on the bottom are just going to go away because I canceled them all out with z's from the top. Now let's see here. The x's, it looks like the x's, the bottom's going to win because I have more on the bottom. So 12 on the bottom, 3 on the top. 3 will cancel. And how many will I be left with on the bottom? Should have 9 left on the bottom. So I should have x to the 9th on the bottom. That 64 is still hanging out there. So, took care of my z's, took care of my x's. Let's look at the y's. You got 6 y's up top, 3 y's on the bottom. 3 of those will cancel, and I'll be left with 3 y's on the top. So I have y cubed on the top. And that is the most you can simplify that guy. So again, this looks scary when you look at it at the beginning, but if we just apply all of our rules, that's not so bad. We just have to do one at a time. Everything gets cubed on the top and bottom. And then we do our power to a power, multiply. And then we're able to just cancel out everything. Let's take a look at this one from your sheet. So we're squaring everything. So we're squaring the top, squaring the bottom. So I can rewrite that as 2mnp, whole thing squared, divided by 2n squared, p to the 4th, all to the 2nd power. Now let's do this one a little bit different. We can combine these to start with. We can combine these, we can cancel things, we can do all of that before we actually bring this 2 inside. So p squared times p to the 4th, that's p to the 6th. So on the bottom now I have 2n squared p to the 6th squared. And on the top I can't combine any of those, so I'll just have 2mnp squared. So now let's apply this. So let's square everything here, and let's square everything here. This time I'm going to do the power to a power at the same time. So at the top here I'll have 2 squared, which is 4, m squared, n squared, p squared. And on the bottom I'll have 2 squared, which is 4 again. Hey, that's nice, those 4's cancel. And then n squared squared is n to the 4th, because I multiply the power to a power. P to the 6th squared is p to the 12th. 4's are gone. No other m's, so the m squared is just going to hang out up top. We got n squared over n to the 4th. So more n's on the bottom, but 2 of them are still going to cancel. So 2 of them go away. The n's on the top are gone. I'm left with 2 n's on the bottom. So I have n squared. And I got p squared up top, but lots more p's in the bottom. So 2 of those p's are going to cancel, and I'll be left with p to the 10th on the bottom, because I can subtract 12 minus 2. Done with the p's, done with the n's, I believe, yep, and I have the m up top, so that's it. That's the most I can simplify that. M squared over n squared p to the 10th. So, a little bit of a tricky one from your worksheet, but definitely doable. And that's it. Homework for tonight is to finish the yellow worksheet. Remember that the answers are on Moodle. The way you get to the Moodle, you click on the big green 7. I can even make it green for you. Ink color, green. So, big green 7. It's a bubble on the page. Click on that 7. And then it's going to bring you to a table. In that table, at the very bottom, it says answers or solutions. I don't remember what it says. But if you click on that, it's going to have all the solutions to these worksheets. So go ahead and give that a click, and you can check all your work. I love you guys. That's why I'm here. Have a great day. If you're going to the hockey game tomorrow, I hope you enjoy it. For those that are coming to class, it'll be a work day. You'll be able to go back and watch these videos if you need some more pointers. Finish up this yellow worksheet. Maybe you didn't finish the white worksheet from Monday. If you have everything done, you can just relax and maybe do some work for other classes. But be nice to the sub. Don't drive him nuts. And look forward to seeing you guys soon. Have a great weekend.